All right, so I think I'm recording. Let's take a look at this problem. They want us to simplify 2 times the square root of 256 times r to the fourth power. And we know that we can split apart the radicals if you have multiplication, that we can look at the square root of 256, and we can look at the square root of r to the fourth. Well, before, all the time we always come down here and break it in, that this is an even number, so we've got 2. Well, hey, why not just try taking the square root of that? If you take the square root of that, then you'll get 16. This 256 is a perfect square. So the square root of 256 is 16. Now, suppose you didn't recognize that, okay? Suppose you just came in like you've been doing and that you blindly, that you're really just trying to break it down to something that you've done every time. 256 divided by 2. So my fracture tree is going to be pretty long here. I get 128. Divide that by 2, and you get 64. Now, 64 is 8 times 8, but maybe you didn't see that. 2 times 32 is 64. Now, 16 times 2, but maybe you didn't see that. Well, here we do want to put 2. And now 16, hopefully you can see that that's 4 times 4. But if you didn't, here's 2 times 8. Here's 2 times 4. And here's 2 times 2. So this 256, how many factors of 2 do we have here? 1, 2, 3, 4, 5, 6, 7, 8. So on your calculator, I claim if you raise 2 to the 8th power, you'll get 256. Well, if you take the square root of each side of this, how many pairs can we get? Well, 8 divided by 2 is 4. We know we're going to get 4 pairs. Here's one pair. Here's a second pair. Here's a third pair. And here's a fourth pair. And that's 2 to the 8th power. Well, if you multiply, this is not 22. This is 2 times 2 each of these. You've got 4 of these. So you have 2 to the 4th power. And 2 to the 4th power is 16. But like I say, if you recognize it's a perfect square, then that factor tree is definitely a lot smaller and a lot easier if you recognize that 16 times 16 is 256. All right. So what that gets us over here is that we have 2, and now we know that we can replace this radical 256 with the number 16. Now, don't forget this is multiplication. So now the variable is a lot easier, because if we come over with r to the 4th power, we know that that's r squared times r squared, and that's r times r, and this is r times r, that when you have 4 factors of r, here you have a pair, and here you have a pair. So when you're taking the square root of r to the 4th power, I don't ever break it down like this, because I just take this exponent and divide it by the index. 4 divided by 2, that's 2. But if we do write it out, just for illustrative purposes, and we know that when you have a pair like this and r comes out, then you have a pair like this and an r comes out. So r to the 4th power is r squared. But like I say, the fast and easy way to recognize that, 4 divided by 2 is 2. So what this scratch work on the right hand side shows us that the square root of r to the 4th power is just r squared, and we don't have to worry about any absolute values or anything like that, because we're assuming that all of our variables are non-negative. Now we do want to be our final answer. We can multiply 2 times 16 and write it as 32r squared. So you wouldn't think that those are the same. There's no way that I would look at this and see 2 times the square root of 256 r to the fourth power and immediately see that that's 32r squared without a little bit of thought. You know, um, maybe it's a little bit easy to see it because the square root of 256 is 16, and 2 times 16 is 32, and 4 divided by 2 is 2. So maybe some people can see it, but it's definitely something that I would work out, show my work, and do all this scratch work that we did. So here's our final answer. I hope that helps, and I'll talk to you later. Bye.